Hello, hello. Welcome to this week's webinar. We have a webinar just about every week on a variety of topics, and we're excited to have a great crowd this week. I'm Jeffrey Palermo, your host for this webinar and chief architect of ClearMeasure. We are a software architecture company empowering your team's software delivery capability. And our hope for you is that your team delivers world-class results. I'm here to present today a DevOps roadmap that can help enable your team to move faster, build your software in a smart manner, delivering top-notch quality, and run your system with confidence. And regardless of the challenge that you're facing, you as a software leader have an important responsibility. And judging from the job titles represented in the attendee list of this webinar, you've got some really big jobs, and the stakes are high. But my hope for you is that you'll be able to take away some information that can help your project succeed. We have a chat pane in the software, as well as a Q&A window, and some of the resources, links to those are going to be put into the chat window. Also, use the Q&A window to ask questions during the webinar. I'm pretty good about answering the questions in line and kind of working those in, but if there's any remaining questions, I'll make sure to answer those at the end if I haven't been able to work them in. So let's go through our agenda. The webinar is organized into just the following topics. We'll talk about the challenge that we're all facing, what it kind of looks like, the symptoms, and then we'll go through the roadmap for how to deliver software much more quickly than maybe some of you are used to, and the details of each. And then we'll talk about some of the value that we've brought to our customers and what kind of assistance that we can provide. Because as a software architecture company, our clients, our companies with development teams, with custom development teams in-house focusing on Microsoft technologies, and we love it when we can help them move faster and increase quality and either jumpstart their projects or just help them improve overall and make your team more self-sufficient. So I want to give you something of value to help you get going and help you get automated. I don't want you to continue to be frustrated and sometimes trapped by the software that you work on that sometimes finds a way to break upon deployment. And I do understand the lost weekends that sometimes happens and surprise overtime due to software builds and deployments that sometimes go poorly. Now, at ClearMeasure, we've helped thousands of professionals across over 40 countries be better at software. And my latest book, .NET DevOps for Azure, exposes the secret about how any team can have a fully managed DevOps pipeline by just following a concrete 7-stage design. And here's what you need to do. First, you need to read the book, and I will give you a free electronic copy just for being here today on this webinar. So just go ahead and send me an email or click through on the link in the chat, and I'll get it to you, whether you're watching live or whether you are a coworker of someone who watched live. So if you want to send this on to coworkers, that'd be perfectly fine. I want you to have this book, and you can also get the print copy on Amazon or anywhere books are sold. And the second thing, you need to understand the 7 stages of a DevOps pipeline. That's in the book. And then third, launch your own .NET DevOps pipeline. Use our public project that's illustrated in the book as a model. You'll find it there, and it works for so many different types of .NET software. And if you do this, then you will have a fully automated DevOps environment using Azure that will enable you to move faster and with higher quality. And even if you're using virtual machines in your own data center, all the principles still apply. In addition, we have announced our quarterly training class. It is the .NET DevOps Bootcamp. And that class is a hands-on, immersive, on the job training style program. And you will do all of what is in the book in the training. You will create your own builds. You will stand up a new architecture. You will create environments, deploy across a multi-tiered environment pipeline. You will do everything necessary in a DevOps environment in that training course, and it's fantastic. So uh, the next resource that may be useful to you is the Azure DevOps podcast. I'm the host of that. It's a weekly podcast. You can go to www.azuredevops.show for the past episodes and show notes. If you're not subscribed to that, do that. It's in all the podcast directories. So now let's get into the meat of this. Um, we have a challenge, and the challenge is shrinking our deployment cycle. And some companies, you may be in this boat, uh, can't deploy except every few months. If you're a little bit faster than that, maybe it's weeks. But we need to get down to days and hours and minutes. We want high speed, but we also want high quality software delivery. And there's some things preventing us from doing that. A lot of the times, our deployments are disruptive and they take a long time and they're error prone. Why do we want to do them more frequently? And there's delays and there's long lead times and there's risks that are just our gut says there's a risk here, but maybe we can't figure out how to articulate it or mitigate it. But there's some root causes that we find that are common across so many client engagements that we have. And a lot of times we find that there's an insufficient work environment for the overall software team. Sometimes we find an incomplete software process. So we aren't tracking the work that's moving through the team. And then the third common root cause that we see is a lack of transparency and measurement. Now, notice that none of these root causes are about C# or about SQL Server or .NET. This is all about the process that we put in place for our team and the environment that we have them work in. And all the technical parts about languages and compilers and libraries and tools, those are all important and they have a place, but it's important to have a strategy and to implement that strategy and measure as we're going along. Now, this is a conventional view of DevOps, and you can see the cycle of plan and code, integrate, package, release, operate, learn. Uh, we set up an automated continuous delivery pipeline, and then we work in short cycles to move software features and changes from the idea stage where we plan things out to production and out to real usage so that we can learn how our customers and how our users are benefiting from the change that we just made. But before we move on, let's touch on the basics of the automated DevOps pipeline, because that is really central here. Now, what you see on the screen, and I know the text is really small, this is a highly shrunken technical blueprint for the structure and flow of a pipeline that is implemented with Azure DevOps Services and Octopus Deploy, and it has a continuous integration build and a 3-tier deployment pipeline. By the way, you'll never have fewer than 3 environments, even for simple applications or microservices. We've done some other webinars that dive deep into all the details of this model, both with Azure pipelines and with Octopus Deploy. Please reach out to us if you'd like some more information on how to set up a software system for continuous integration and automated deployments. And remember, it's not just the front end of the application, but also the database. You need to be deploying that database with the application that owns it. But you want to have your automated DevOps pipeline, and this is the general structure, regardless of what type of .NET or .NET Core application that you're working with. Now, this is just the top third of a detailed architectural poster on this. If you're interested in that poster, a link has been placed in the chat. Just go ahead and click on that. And by the way, this is meant to be an architectural poster. We throw in some products to be illustrative, but there's other build servers on the market, and they work well. You can integrate any number of tools. It's not about the tools. It's about how you put them together, and that all of the important parts of the process are accounted for. All right, so now let's go into what you need to think about. And I want to illustrate how to think. Let's talk about the challenge of our industry with an analogy. So there was this there was this new business owner that wanted to create a new auto mechanic shop. And so he buys a beautiful new piece of property on a good street and builds a top-notch building, orders some brand new tools and equipment, thinking, I'm going to do this right. I'm going to spare no expense. And he goes to the local auto mechanic trade school, talks to the dean of the school, says, I want to hire your top tier from your next graduating class next month. And so graduating day comes, and he hires the best of that graduating class. He pays what it took to get the top of that class. And then they're all standing out in front of the beautiful new building with the crates of brand new equipment and tools, and the owner is kind of briefing them and really excited, and then announces, okay, next week is going to be opening day. Let's get ready, team. And he walks away, leaving the freshly minted mechanics to get set up, and he's is beaming ear to ear, smiling, proud of himself, and excited about opening day. And the staff, the new graduates, top tier graduates from that auto mechanic school, they look at each other wide-eyed in fear. They have no idea what to do. They were trained in a shop that was professionally set up for them. Nowhere in the curriculum were they ever set up their own shop. And that's a big problem that we're faced with here in this industry. I think that everyone on this webinar, and the people that we have, you guys are really experienced. But think about it. You learned how to set up an environment for project management, for work tracking, for source control, for builds and deployments, for everything that you do on the job training. It's not in any classroom curriculum. And still to this day, the college curriculums and all the different education mannerisms, they don't teach how to set up a team for success. And so you as a software leader, it is your responsibility. It's a big job, but that's what I want to go through. The items that you need to think about in order to equip your team to deploy much, much more quickly than maybe they are now. So let's talk about the different layers of capability in order to shrink the deployment cycle. Now, of all these layers, each of them must have a sound strategy, be executed with discipline, and have objective measures. It's not enough to say, for example, that you've equipped your team with quality control and defect removal, for example, unless you choose what techniques that you have. So that is, the strategy is the selection of the defect detection methods. And, in this case, we do benefit from research. So Capers-Jones, he has published a lot of research, and he spells out the combination of defect detection methods that are proven in our industry to achieve the needed quality. And so our strategy is taking all the information that we have and making a choice of what quality control, of what defect detection methods that we're going to implement for our team. And let's quickly touch on the layers that make up a complete work environment, so that we can shrink our cycle time and deploy much, much more quickly and more often. Now, one of the example best practices, as we go from the inner layers to the out, one of the example best practices that's commonly selected is the use of what Capers-Jones calls stable reusable components, essentially libraries. In .NET, NuGet packages. Now, this practice is backed by research data that it drastically cuts down on custom development costs. And so you want to use, and you are using, those NuGet packages or those Node packages. They're everywhere. Now, even among teams that have said that they do this, we often find large sections of code that could have easily been replaced by a library and not custom developed. And that's whether it's open source or a commercial library. And we often find that team managers are often unaware of the missed opportunities to save significant chunks of schedule, and maybe we're unaware of the existence of all of this custom code that was built instead of bought or even gotten for free. And so we need a declaration of this practice, and we need a measurement to see if if our teams are often and working on things that really should be a library. And so back to defect removal, there is some research around distribution of defects. For every 5 defects, according to research, for every 5 defects, about 1.75 out of the 5 is a problem with the code. About 20% of those, that's 1 out of 5 defects, are requirements problems or requirements flaws. 1.23, which is over 20%, is due to a design problem. And then, of course, almost 10% is due to bad fixes where we tried to fix a bug and then just created another one. If you want to dive more into the research behind this, you can look up Capers-Jones's 2012 white paper called Software Defect Origins and Removal Methods. And that link will be posted in the chat. But again, the title is Software Defect Origins and Removal Methods. And based on the type of software we have, we need to strategically select the defect detection methods and the defect removal methods that are shown in the research to get us above the 85% defect removal, which is really the line for malpractice if we're below that, and up into the high 90s for our teams to really say that, hey, we're delivering quality. And interestingly, just another tidbit, one of the worst offenders in introducing defects into a code base is just going and grabbing code from any source, whether it be copying and pasting it from Stack Overflow or grabbing a NuGet package that really isn't vetted. And in the research, it's called unapproved reused code. That's kind of the term research is shown. So, and NuGet is great for packages that are strategically identified, but there's no vetting by Microsoft. Anybody can just throw up a NuGet package and even intentionally have malware or problems, but a lot of times it's just not properly vetted. So you want to strategically choose that as you move along. All right, the next layer is team workflow. And you know, before I go into team workflow, I want to talk about, I want to go back and just make one more point about best practices. And I didn't mention, but you see on the left side, there's all these best practices. There are so many practices that have been labeled best that it is logistically impossible to use them all on a given project. It's just not possible. Some of them overlap, some of them kind of present an either or. There are so many great practices out there, but you can't just, if you say, and of course we use best practices, you're not saying anything because it's impossible to use all of the best practices that are out there and available for us. So the strategy around this is choosing which practices, okay? That's really important. Strategy is all about choices and trade-offs. So I wanted to make sure that I mentioned that. Now back to team workflow. Most software project tracking tools use swim lanes or statuses to move a piece of work through the process. I'm going to show you an example to that. But we find that far too many teams have too few of statuses. The not started, in progress, done structure does not really do anything for you. And if the motion of the team or the work of the team doesn't reflect in the work tracking tool, then you're going to have bottlenecks that happen. They're going to remain hidden and they're going to sap your schedule. And a complete workflow sheds light on every bottleneck that starts to happen, starts to crop up, and enables the team to have a constant and predictable flow that can be tuned and measured. And to dive into that a little bit more, I want to talk about cycle time and the different cycles in your team that you need to design. Now, this is one of the principles within what we call Onion DevOps. And if you look at the various cycles, the coding cycle is an individual programmer, an individual developer writing code, seeing it run, writing code, and then making a check into their branch. The team cycle, and then the product cycle and the customer cycle, each is encompassing more and more. And so when we deploy to our customer, we have to execute multiple product level cycles, which is multiple trips to a UAT or a staging environment with a new software build to make the decision, hey, are we ready to go to production? For each of those, we need the team to produce multiple builds that are a release candidate that can then be shown to our internal product level stakeholders. And to produce a team build, we have to have multiple Git commits on feature branches and multiple pull requests by individual developers. And then, of course, on the outside layer, the support layer is whenever a hotfix. It's the cycle time of when a problem is reported and how fast can we get that hotfix um, resolved. So in any process, there is a set of concentric circles of cycles, and this is the cycle time view of the Onion DevOps model. And individual developers will code and run many cycles before pushing the code to their teammates so that the team can produce a build that can then be shared with someone in product management, who in turn will evaluate multiple builds to determine a build to release to the customer. The customer will use the software and make requests of changes, and then we'll have a hotfix support cycle. And a lot of times out in production, there's going to be a problem. Maybe it's a user error, maybe it's a data issue, maybe it's a showstopper bug. But with a refined process with deterministic and controlled cycle times, you can triage the support ticket. You can use the telemetry built into the system and know exactly what to do in order to have a fast cycle time. Now, if code does need to be changed, then the customer support team will be able to reproduce the issue and get it to whoever is in charge of your product management, who will then decide whether to stop the presses to work on that or to maybe schedule the fix for the next release cycle. When the ticket is cleared for work, the team will take it and make sure a solution is understood, and then the team dispatches it to an engineer on the team to change the code, running through a code cycle on the inside, and then committing the code back to the feature branch so that the team can produce a build, accept the pull request, and provide that build back to product management, who will then verify the fix and then clear it for release. Then the customer will use the new build of the software and verify that they are now unblocked and the support ticket can be closed out. So this process always happens. It's about, are you tracking it in a visible way? These nested cycle times are the structure of your DevOps process that's going to allow you to deploy in hours and not weeks or months. And with this, you are intentionally controlling the process of each cycle so that you have that predictability. And then if you're not happy with the speed of a particular cycle, you can change it. You can analyze the steps that have to happen, how long each one takes, and then determine what to do to fix it. If your software has no observability characteristics, for example, you'll be stuck at the support ticket level trying to reproduce a problem, banging your head against the computer. You'll expend a lot of effort trying to determine if the issue exists for just one customer or if it exists for everyone, if it's a data issue, configuration issue within just one environment, or if some source code is the problem. And it will take a long time to figure out what to do and who should be pulled into the issue. And just as an aside, telemetry is a tool that you can use so that you build into the system more observable characteristics. Just like our industry went through a testability and test-driven development revolution 15 years ago. And by the way, for those of you who with less than 15 years in the industry, there was a time when people questioned whether building in automated tests was even worth it. Now it's an accepted and proven practice. It's proven to be worth it, and is one of the top 3 defect removal techniques that's proven in research. And not writing tests in this point is considered malpractice. And it's a good point of industry maturity. Now, back on the telemetry front, logs have long been something that's have been casually done. But with faster cycle times needed by the businesses that we serve and work for, we need to add the architectural characteristic of observability to our software system so that we know at all times what they are doing so that we can tune and shrink these cycle times. Now, on workflow, this is a sample Kanban board. Please, if you have the not started, in progress, done type board, please copy this. This is in my book as well. And notice that there are 4 different columns before the development column. You have the conceptual definition, which is the business side of the requirements. Then the user experience design is how a human is going to interact, whether it's the wireframes or whether it's just characteristics of speed on the back end. Then the technical design is the architectural changes that need to be brought in, or deciding about what library is going to be brought in, or what design patterns are necessary for this new feature, or just to verify that, hey, the architecture is sufficient for this new feature. Nothing significant needs to change. It's just some code change. Moving on through, and then test design brings us our definition of done and gives us the scenarios that can be coded as full system tests with the feature. And if you haven't heard of that practice, you can research acceptance test driven development. And then on the back end of development, we have the different layers of validation. And you see those concentric cycles kind of flattened out into a work tracking board. And you need all of these columns to be able to know where your time is going. Because a lot of times things will stack up in development. We'll ask developers, hey, why is this taking so long? When really a design decision of the previous 4 columns was sometimes missed. And now our developers are trying to catch up and fill in those gaps, and then we wonder why things take so long. So it's really important to get your workflow laid out properly. The next layer is your architectural blueprints. Now, the best model that we know of is from 1995, the 4+1 view model of software architecture. It was developed by Philippe Christian of Rational Software Corporation, and it is a model for iterative emergent architecture. Now, strategically, you are defining what is being built, what is cleared for investment, and what is deferred, because we're going to defer a lot of things. We're going to declare that, hey, it's not supported right now. Now, every professional that builds something uses design drawings and design models in the communication of what is to be built. And teams that lack this are constantly struggling to place the same image in the minds of every team member. And across all of our clients, we often ask about how the system is structured. Hey, can you show us the architecture? And far too many times, we spend over an hour in a conference room harvesting the architecture out of the heads of the team members and drawing it up on the whiteboard. Architectural blueprints is the definition of what is to be built or what you have, and it's a tool for team alignment. Without it, you can't have the same image in every brain on your team. Imagine a business with no business plan or market strategy or quarterly goal. It's hard to get alignment. And finally, let's talk about cloud operations. Operating the software system is how we provide business value, because there's either internal users or external customers. And if we rely on a user, for example, to report an issue, we're going to only capture a subset of available information. We should see that a user is struggling, much less if they receive an error. And if they're internal employees, we should be calling them and say, hey, I noticed that you had an error. Can I help you? They shouldn't have to wait until they get frustrated and finally submit an issue. But many teams have some logs, but not nearly enough. And in some cases, someone with administrative access has to log into a production server to get to the logs. There's no aggregation, no performance timings. The goal here is to make the software system completely observable, to know what it's doing at all times. It's really important. So to review, these are the capabilities, and we need to have a strategy for every capability. That is, make choices of what practices, what tools we're going to use in every area. We need to implement that and make sure our team is executing that in a consistent way. And then we need to measure to make sure that the choices that we've made in our strategy are actually getting the desired effect, so that your team can move fast and build that system in a smart, quality manner and then run it with confidence. Now, we've seen this model make a huge impact for our clients. Here are some of the video case studies that we have on our website. Pop Hutchison was completely transformed when equipped with this model, and when any team is equipped with a complete professional work environment and a strategically determined process, we see those teams truly become world class. And we hear of teams who move fast at Google and Netflix, Microsoft, Facebook, but any of your teams can be just as effective when equipped properly. You absolutely can. So, what's next? Well, for first off, you need to get down the road to up-leveling your team to be a self-sufficient software factory or DevOps factory. And there's various ways that we can do it. We do a lot of project jump starts. If you are starting on a new project and you need to get that normal pace, that normal cycle going quickly, we do a lot of project jump starts to get you going in the right path as a software architecture company. We also do a lot of inspections of your current processes to identify the gaps, and we do a lot of uh, DevOps plans and DevOps implementation to modernize your existing development environment for your existing applications so that you can move faster and get the releases on a quicker cycle that you are now. And also just general software architecture to work through tough problems, performance problems, whatever it may be. And so we're here for you. And the clients that use us report that they then have to outsource less to development companies because the internal development staff are up leveled and have a greater capability and are moving faster and have increased quality. Now, make sure to get the book. If you haven't requested the electronic copy, get the book. It shows a complete DevOps environment from work tracking, source control, builds, multiple levels of testing, everything that you need is in there. And it provides a pit of success configuration. And it is focused on .NET Core, SQL database. It does use Azure environments, infrastructure as code to automatically create those. But the principles also apply to data center based or Windows VM based applications. And there are some shortcut links that that you can use, but for you managers there, just to set your expectations on a new project, your complete DevOps environment should be completely done in the first week of a project. You need to get on with feature development. And a lot of cases, you can have the full setup in 2 days from scratch in 2 days. We often get the basics in 30 minutes. I mean, from absolutely scratch to deploying across various environments for a brand new application, that only takes 30 minutes, okay? Because it's highly templatized. We've got all the templates. A lot of it's in the book as well, but that's a 30-minute thing. But then you need to start implementing the custom things of your architecture, and once you have the deployment pipeline completed, then an architectural adjustment or the addition of a new project or whatnot, you are actually doing feature enhancements instead of doing weeks and weeks and weeks of initial setup before you finally get any kind of build that you can deploy and demonstrate. You need to get into regular feature development right away. And so that's what this provides you. So I think that I've been going through and pretty good. I covered the questions that had been submitted. If there's any more, I think we covered them all unless a late one comes in. But I wanted to make sure that you had my direct contact information. You can call me on the phone. I'm happy to talk. We have a chat on our website, interactive chat, as well as my email address and my Twitter. Reach out, get in touch, make sure to take advantage of the resources, because equipped with these capabilities, every single one of you and your team can deliver world-class results. And I love seeing development teams succeed. And it is just fantastic to see the transformation that happens. So, hey, thank you so much for your time. And I appreciate the questions that did come through and the attentiveness. Please send this recording when you get it to your coworkers so that they can benefit from this. And if you have any webinar requests or topic requests, please send those in as well, because we like providing as much value as we can and empowering every developer and every development team to achieve more. Have a great day.